Hello class, this is Roger Palomino again here, episode 5, here to help you guys talk about another topic of transformation of functions. This is the second part where we're talking about stretching, shrinking, and even reflecting of functions. So let's see, where are we? So we're going to talk about that. So let's start off with suppose C is a constant that's greater than 1. To obtain the graph of y equals f of x, you have to stretch. Sorry, hold on. I meant to put not y equals f of x. It is y, but it's c f of x. That's what I meant to put because we're talking about c, the constant. Stretch the graph of y equals f of x vertically by a factor of c. Now for the next one, y equals 1 over c f of x, shrink the graph of y equals f of x, vertically by a factor of c. Now, if we have a constant that was in the function, let's just make this a little different. Y equals f of x c x. There we go. So you see there's a c inside here. You still have to shrink the graph of y equals f of x, but this time you do it horizontally by a factor of c. Okay, next we have y equals f of x over c, a fraction. You do the opposite. You would stretch the graph of y equals f of x horizontally again by a factor of c. Now let's see, the next one would be negative x. You have to, when you have a negative sign here, you can see that when I say y equals negative f of x, you have to reflect the graph of y equals f of x about the x-axis. Now, there's one more case. I'll write it on top. If you guys can't see that, let me just erase the first one then. So let's see. The last one here talks about, you're still reflecting, but the y, the negative sign, is going to be within the function. So you have to reflect the graph of y equals f of x about the x-axis. So now, what does all this mean? Okay, so think of it this way. Just like I already told you with the same eraser board, I told you can move it over, you can move it up, you can move it to the left, right, depending on what your function is, you're able to stretch it, you're able to move it, but this time you're allowed to stretch. If I could stretch this thing, you could stretch it horizontally or vertically depending on the function, and depending on the value of c, it'll determine one of these 6 cases, okay? So now let's give some visuals, because we need some visuals here, because all this is gibberish if you don't know how it looks like. How does the function look like? So I'll give you guys two different examples of functions that relate to some of the cases here. So our first example, y equal cosine of x. So we know what the cosine looks like. It starts at 1, and then it goes down, and then up, and it repeats the pattern in this fashion. Now, let's say I gave you y equals 2 cosine of x, right? What this is telling you to do is, instead of starting at 1, you start at 2, and then you continue to draw the cosine function in this fashion. Now, y equals 1/2 cosine x, that's the other one. Now, for this one, this is telling you to start, if you guys can't guess, this is going to start at 1. This is going to start at 1/2. So, as we can see, when you're multiplying by a whole number here next to the cosine, it stretches it up depending on how many units that's being multiplied. So it's stretched up a bit, and if you multiply by 1/2, it shrinks vertically. So those are the first two. Now the other ones, let's see. Let's use a different example here. Okay, so for the other ones, we'll be using y equals the square root of x. Now, visually, if you remember, it just starts at the origin and it shoots up to the right. Now, if I gave you y equals negative root x, right? Instead of shooting out to this side, if you had a mirror, it would reflect on the opposite side on the second quadrant. So it will go shooting out on this side. So it shoots out to the left. Sorry, not to the left, sorry. I made a mistake. That's if the negative sign was within the function, sorry. It actually it mirrors it down, sorry. So it goes down this way. That makes sense because no matter what value I put in, it's going to be negative because of the negative sign outside of it. Now, if I gave you y equals 2 root x, you'd stretch it a little bit on the y-axis so it goes up more instead of shooting out to the right. Now the last one I was going to talk about, which was the root when the negative is when it's inside the function, it's going to be reflected about the x-axis, so it's going to shoot on the other side. So that's the one that I was talking about earlier. So it shoots off to the other side. So there's a whole bunch of things in mathematics that is very fascinating, that you're able to do so many things with functions that you can manipulate them in such a way that they're stretched, they're moved, they shrink, and they can be reflected as well. There's a whole bunch of other things you can do with them, and I will get to that, but those are generally all the transformations that you can necessarily do with functions. And it's a very good visualization of what it is we have here. So, if you have any questions, leave a comment, share, like, and subscribe to this video, and be sure to check the bell button if you want more notifications for Absolute 5. And by the way, this is Absolute 5. I'm Roger Palomino, and math is infinite.